Hi everyone. In this video, I will explain how to obtain the transfer function for a small electrical circuit. In this example, it has a small electrical circuit consisting two resistors and two capacitors. Resistors are R1, R2, capacitors are C1 and C2. The input signal of the excitation function is theta I and output signal is theta naught. The definition of transfer function is it is the ratio between input and output signal. We can write the transfer function Hs is equal to theta naught over theta I, both are in S domain. Now the circuit is represented at the time domain. This is the impedance value of R1 and this is the impedance value of R2 and this is the impedance value of C1 and this is the impedance value of C2. And first we have to convert this circuit into the S domain. The step one is convert into the S domain. We'll draw the circuit again in S domain. It has two resistors and two capacitors. And this value is theta naught. And my input is theta I. This value is R1 and this value is R2. For impedance of a capacitor, we can represent in S domain in 1 over Cs. For capacitor 1, we can write 1 over C1S. And the capacitor 2, we can write it as C2S. Then we can apply Kirchhoff current law and Kirchhoff current voltage law to solve this circuit. Now I will write it. The voltage of that point is V1 and voltage at that point is V2. And I mark current. This is I1 through the R1. This one through the R2. Current is I2. And through capacitor 1, current is I3. This one I mark as I4. Then I will apply KCL to the V1 place. According to the Kirchhoff current law, it says the total incoming current is equal to total outgoing current. For this node, incoming current is I1 and it is equal to outgoing current. There are two outgoing current, I2 and I3. This is the equation. For the I1, we can write it as based on voltage and impedance value. Then we can write theta I minus V1 over R1 is the I1 current and it is equal to I2 plus I3. For the I2, we can write V1 minus V2 over R2. This is the I2 plus, and for the I3, this voltage is equal to 0. Then V1 minus 0 over our impedance value is 1 over Cs. 1 over Cs. Then we can write theta I over R1 minus V1 over R1 is equal to V1 over R2 minus V2 over R2 plus V1 C1S. This is C1S. Then I rewrite it again. Theta IO R1 plus V2 over R2 is equal to V1 times 1 over R2 plus C1S plus V1 R, sorry, 1 over R1. It's 1 over R1. This part and this part. This is my first equation. Then I can apply the Kirchhoff current law to the V2 point. KCL to the V2. For that one, incoming current is I2 and outgoing current is I4. I2 is equal to I4. For the I2 value is V1 minus V2 over R2. V1 minus V2 over R2, and it is equal to V2 minus 0 over impedance value of capacitor 2. V2 minus 0 over 1 over C2S. Then I will simplify the equation. V1 over R2 is equal to V2 times 1 over R2 plus C2S. And V1 is equal to V2 times R2 1 over R2 plus C2S. And the voltage at that point is equal to theta naught. That is our output. V2 is equal to theta naught. Then we can write this equation again. V1 is equal to theta naught 1 plus C2 R2S. This is the second equation. When we consider the first equation, in here unknown term are V1 and V2 value is equal to theta naught. We can assign this V1 value to the first equation. From first and second, we can write theta I over R2 plus theta I over R1 theta I over R1 plus theta naught over R2 is equal to V1 times this part. Now V1 is this one, theta naught 1 plus C2 R2S into 1 over R1 plus C1S plus 1 over R2. Then we can simplify the equation. Theta I over R1 is equal to theta naught minus 1 over R2 plus 1 over C2 R2S 1 over R1 plus C1 is plus 1 over R2. Then you can see we can get a relationship between theta I and theta naught. Now I will write the theta naught over theta I. It is equal to our transfer function is equal to 1 over R1 1 plus C2 R2 is 1 over R1 plus C1 is plus 1 over R2 minus 1 over R2. This is the transfer function of that simple electrical circuit. You can simplify this equation. Now I will write the final simplified version. R1, R2, C1, C2, S squared plus S times C2, R2 plus C1, R1 plus C2, R1 plus 1. Numerator is 1. You can see the polynomial of the numerator is to the power 0. And here the maximum s to the power value is 2. And this is the final transfer function of that electrical circuit, this simple electrical circuit. It has two resistors R1 and R2 and two capacitors C1 and C2. And this is the final transfer function of that circuit. I hope you will understand how to determine transfer function of a simple electrical circuit.